Today we are going to learn the basics of probability. What is probability? Probability tells us how likely an event is going to occur. For example, if we toss a coin, we either get a head or a tail. So we normally say there is 50-50 chance of getting a head or a tail. In probability world, we say probability of getting a head is half or it is equal to 0.5, which is nothing but saying there is 50% chance of getting a head. But how did we get this value of half or 0.5? Before we understand that, let's see few basic terminologies used in probability. Random experiments. What are random experiments? Random experiments are those where we cannot predict the outcome in advance. For example, if we toss a coin, we can either get a head or a tail. But can we tell before we toss a coin whether we are going to get a head or a tail? No, right? Similarly, when we roll a die, we cannot predict what number is going to show up on the die. So, since we cannot predict the outcome of an experiment, these are called as random experiments. Next thing that we need to know is what is an outcome of an experiment. When we toss a coin, we get either head or tail. Outcome is nothing but the result of a random experiment. So, outcome is also represented by the symbol omega. When we roll a die, there are 6 outcomes. 1, 2, 3, 4, 5 and 6. So if we take all the outcomes and put it in a set, it is called a sample space. Sample space is nothing but a collection of all possible outcomes. It is represented by the letter S. So we've learned about random experiments, outcome and sample space. Sample space is very important in finding the probability of an event. So let's see how to find the sample space of an experiment. A coin is tossed twice. Find the sample space and find the number of elements in the sample space. So let's see how to do it. So when we toss a coin, we either get a head or a tail. That's the first toss. So we toss the coin again. Suppose we get a head, we get either head or tail in the second toss. In the first toss, if we get a tail and we toss the coin again, we can either get a head or a tail. So the sample space is head, 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 tail, tail, head and tail, tail. So the way we write sample space is HH, HT, TH and TT. So we also have to find the number of elements in the sample space. Number of elements in sample space is pretty easy. There are 1, 2, 3 and 4 elements. So there are 4 outcomes in the sample space. Very easy, right? I have explained the solution in detail, so you can pause the video and take a look at the solution. Next thing in probability that we have to know is an event. Event is nothing but a outcome in a sample space, or it can be a group of outcome in a sample space. Event is also called a subset of the sample space. For example, we saw the sample space when we toss a coin 2 times. It could be head, 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 tail, tail, head or tail, tail. What is an event where only one head occurs? So there are 2 outcomes where only one head occurs. So we can write event E is equal to HT, th. So we see that event is just a subset of a sample space. Now that we know what an event is, let's see what the probability of an event is in theoretical probability. Theoretical probability or classical probability says the probability of an event E is equal to number of outcomes in E divided by number of outcomes in the sample space. So here in theoretical probability, we assume that all outcomes are equally likely to occur. Which means that like if we toss a coin, both head and tail are equally likely to occur. That's what we mean by all outcomes are equally likely to occur. To understand this concept better, let's do a problem. A die is thrown. Find the probability of the following events. A number less than or equal to 1 will appear. So when a die is thrown, what is the sample space? Sample space could be 1, 2, 3, 4, 5 or 6. So the event, let A be the event where a number less than or equal to 1 will appear. So A could be, there is no number less than 1, so it could be only 1. So probability of getting a number less than or equal to 1 is equal to number of outcomes in the event A divided by number of outcomes in the sample space, which is equal to 1, there is only 1 outcome divided by total 6 outcomes in the sample space. So the probability of getting the event A is 1 by 6. So one thing we have to note that is the event A is also known as simple event because it has only one outcome. Wherever there is one outcome in an event, it's called as a simple event. Let's look at the solution now. The next question is, a prime number will appear. So we already know what the sample space is. Okay, and we know that number of outcomes in the sample space is equal to 6. So let B be an event where a prime number will appear. So what are the prime numbers in this sample space? It is 2, 3 and 5. Note that we only have to look in the sample space to find the event. Okay, so probability of getting a prime number is equal to number of prime numbers that can come divided by number of outcomes in the sample space, which is equal to, here n of p is equal to 3. 1, 2, 3. 3 by 6, which is equal to 1 by 2. So the probability of getting a prime number when we roll a die is equal to 1 by 2. Forgot to mention one thing. Here the event B is also called as a compound event. What is a compound event? An event which has more than one outcome is called a compound event. Next, let's take a look at these two problems. We already know the sample space, okay, and a number more than 6 will appear. When we roll a die, can a number more than 6 appear? No, right? If C is an event where a number more than 6 appears, it is an empty set, which means that number of elements in this event is 0. So probability of getting a number of more than 6 is NC by NS, which is equal to 0 by 6, which is equal to 0. So here C is also known as an impossible event. When the probability of an event is 0, it means that event will never occur. Okay, that's why this is also called as impossible event. And now let's take a look at the fourth problem. This is the third one. Let's take a look at the fourth one. A number less than 7 appears. If D is an event where number less than 7 appears, 1 is less than 7, 2, 3, 4. All the numbers in a die are less than 7. So n of D is equal to 6. So probability of a number less than 7 appearing is equal to n of D by n of S, which is equal to 6 by 6, which is equal to 1. When the probability of an event is equal to 1, it's also known as a sure event. So in this case, we know that the numbers 1 to 6 will always occur. It will always occur when we throw a die. In a sure event, the event D is equal to the sample space. I have printed out the solution, so you can pause the video and take a look at it. Now that we've understood how to find the probability of an event, let's take a look at the rules of probability, which is also called as axiomatic approach to probability. You know that the probability of an event is always between 0 and 1. If the probability of an event is 1, we saw that it is called a sure event, or it's also called a certain event, which is definitely going to occur. If the probability is 0, it's called an impossible event, which will never occur. So, as the probability approaches 1, then it means that event is more likely to occur. Similarly, if the probability of an event is approaching 0, it means that the event is highly unlikely to occur. The next rule says sum of probabilities of all outcomes or sample points is equal to 1. If you take the example of rolling a die, there are 6 possible outcomes, and each of the outcome has a probability of 1 by 6. Now, if you add the probability of each of the outcome, let's see what happens. It is equal to 6 by 6, which is equal to 1. So, the sum of probabilities of each outcome in a sample space will be equal to 1. Let's see few examples and apply the rules of probability. Which of the following cannot be a valid assignment of probabilities for outcomes of sample space? Here, each of the sample space has 6 outcomes, and we have to figure out whether the probabilities assigned to the outcomes are valid or not. Let's look at the first problem. All of the outcomes have a probability of 1 by 6. So, all the probabilities are between 0 and 1. So, the first rule is valid. Now, let's add the probabilities of each of the outcome. It is equal to 1. So, the probabilities of all outcomes, when we add it, it is equal to 1. So, rule 2 is also satisfied, which means the probabilities of these outcomes are valid. Now, let's take a look at the second problem. In this problem, the first outcome has a probability of 1 and 0 is assigned as probability to all the other outcomes. Probability could be either equal to 0 or 1. So, rule number 1 is still satisfied. Now, if we add up all the probabilities, it is still equal to 1. So, rule number 2 is also satisfied. So, these are valid assignments of probabilities. Let's move on to the next question. If you take a look at all the probabilities, do you see anything odd? If you see the probabilities of last two outcomes, they are negative. Can the probability be less than 0? No. Probability cannot be less than 0. So this is not a valid assignment of probability. Let's take a look at the next one. You see the probabilities assigned. Do you see anything wrong with it? If you look at the value 3 by 2, it is equal to 1.5. Can the probability be greater than 1? No, it cannot be greater than 1. So this is incorrect assignment of probability. Let's look at the last one. If you see, all the probabilities are between 0 and 1. So rule 1 is satisfied. Let's add up all the probabilities. It is equal to 2.1, which is way higher than 1. This is not a valid assignment of probability. Hope you have understood the basics of probability with this video. If you like this video, please click on the like button and share your comments. Thank you.